Hello and welcome to another one of D's ADD videos. Today we're going to be looking at E2 reactions. How do we know it's an E2 reaction? Well, we need a strong attacker like RO-, the alkoxide ion, and either the substrate needs to be big, the electrophile needs to be big and bulky, or the attacker, the base, needs to be big and bulky. Alright, so our preference for the E2 reactions are going to be 3, 2, 1. And if I, in this case, have a secondary carbon, I'm okay, and I have a strong attacker, and I have an anti-coplanar hydrogen. What can happen here is I look for the hydrogen that's anti to this bromine, and because of the straight line there, they're going to be on the same plane. So here we're going to have this not drawn hydrogen be the anti-coplanar hydrogen. That's one plausible place. There's another one that's right here that's not drawn. That's plausible as an anti-coplanar hydrogen as well. Okay. So let's look at the possible products. The first product that you might see when ethanol, or actually methoxide, comes and abstracts this hydrogen, you'll be left with these electrons that come and form a double bond there. So for that product, we would get a double bond, then the rest of the compound. And if I abstract this hydrogen here, the electrons will go over here to where the gap would be when the bromine leaves, and I would get a double bond there. Okay, and actually the double bond would make it to where they're flat, I believe. So bring everything to a plane. Okay, so this one is mono substituted. This one is 1, 2, 3 substitutes, so try. So this would be your major product. This would be your minor product. Alright, and that's basically it. We could look at a slightly more complex example. Let's do a cyclic compound. We'll put our bromine here coming out at us. And I'm going to put a methyl group going into the page here. And let's use this same attacker. What's going to happen is we're going to abstract an anti-coplanar hydrogen. So because of this methyl group right here being into the page, that means the hydrogen is coming out at you, and it's not going to be anti to this bromine. However, on this side, we have two hydrogens, and one of them indeed is going into the page. So I can abstract that hydrogen, leave these electrons behind to form a double bond there, and you would get something like this. Okay. Again, the concept is the same though. Abstract the hydrogens that are anti and coplanar and form a double bond. Not too much to these, you just have to make sure you pick the right hydrogens. practice, 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 and make sure you also check out the Hoffman product. What will happen in these is if there's multiple choices for double bonds, usually it's Zatsiev's rule, right? But let's say I use a big and bulky attacker like T-butyl oxide. Can't spell. Luckily this is not a spelling tutorial. T-butyl oxide looks something like this. And that's huge, and what will happen is this will lead to what's called a Hoffman product. And the Hoffman product is where the least substituted is the major product. And make sure you watch that video as well. But basically, in the presence of this, then we usually have the opposite of Zatsiev's rule. Alright? So thank you. I hope I've cleared up any confusion that you might have. Make sure you practice. That's the most important part. And have a nice day.